Malware is a broad term for any software intentionally created to cause harm or something illegal or unethical. It can steal data, damage files, and hijack systems, or simply spy on users. Malware is not about money, it can also be about power, control, surveillance, and sabotage. Each malware strain is typically created in specific goal in mind. Each type has different delivery method and effect on the system. Understanding these helps analysts identify and categorize threats more accurately. These examples will show how malware can be used for cybercrime and how these attacks impact financially and politically. Malware isn't just an IT problem, it can be economic and geopolitical threat. That's why malware analysis is such a crucial skill in cybersecurity today. Now that we have understand what malware is, now we'll explore why is it important to analyze and reverse engineer malwares. Welcome. Today we are going to understand why malware analysis isn't just a technical skill. It's a critical part of modern cybersecurity. We'll look at how it's used in real world to detect, defend and respond to malware threats. Malware analysis is just like digital forensics. We examine malware to find out what it does, how it does, and how to stop it. Whether through code injection or behavioral observation, the goal is to extract actionable insights. Malware analysis enables defenders to stay proactive. It's essential in developing detection signatures. In incident response, malware analysis helps pinpoint how a breach occurred, whether other systems are affected, and what data may be compromised, allowing teams to act fast. Threat intelligence relies on malware analysis to build knowledge about adversaries. It helps create profiles of threat groups and anticipate their next moves. For security operation centers, malware analysis powers stronger detection logic. Instead of waiting for alerts, the malware analyst can proactively search for signs of infection. AV and EDR tools are only good as intelligence behind them. Malware analysis helps security vendors adapt quickly to new variants and stealthy techniques. In legal context, malware analysis can uncover digital evidence that links attackers to specific tools or campaigns, which is critical for prosecution and attribution. The open source research community helps global community to stay informed, which also builds the next generation of analysts and defenders. Whether you are a part of blue team or a researcher or a forensic investigator, malware analysis equips you to respond intelligently to threats, not just to react to them. In this section, we'll discuss the ethical and legal frameworks that guide malware analysts. Understanding what's legal and ethical ensures your work remains responsive and safe. Without guidelines, analysts might unintentionally break laws and put others to risk. Staying with legal and ethical boundaries ensures we protect users and system and ourselves. Even analyzing malware locally can be a legal gray area. Always ensure samples are handled securely and you are not accidentally violating local laws and terms of service. Safe handling is both a technical and ethical responsibility. Even careless mistake could spread the malware or leak sensitive information. When you discover something dangerous, act responsibly. Sometimes Analysts cross lines unintentionally. Being aware of these common pitfalls can help you avoid reputational or legal trouble. Remember, just because something is legal doesn't mean it is ethical too. Before analyzing the malware, setting up a properly isolated environment is crucial. In this module, we'll cover how to safely contain malicious code, avoid leaks, and replicate real world behavior in secure sandbox or a virtual lab. Why isolation matters. Running malware on non-isolated system is dangerous. You could infect your own machine, your network, and violate all legal guidelines. Isolation is your first line of defense. Host system precautions. Your host should never become a bridge for malware. Double integrations that leak data or allow cross VM interaction, even clipboard access, is a risk. Network controls. Not all samples require internet, but when you do allow connectivity, use tools that simulate servers or inspect traffic in real time. Never connect a malware VM directly to your open network. Tools for safer analysis. Use pre-built environments like Flare VM or Remux to save time and stay consistent. If you are handling advanced or persistent malwares, consider a OS like Cube's OS. Always log what you are doing and never trust a single sandbox. Some malware behaves differently in VMs or tries to invade based on environment. Some malware detects that it's running in a VM and hides its real behavior. Some tools will help test an anti VM detection. Simulating real behavior with a fake interaction can also coax the malware into action. Common mistakes to avoid. Even experienced malware analysts make mistakes. Never analyze multiple samples in same VM without reverting. Malware can persist or interfere with your analysis. Always think of the containment first. Skipping isolation can cost your data, your job, or even worse. Essential tools for malware analysis. This module introduces the key tools you'll use throughout your malware analysis journey. These tools will help you inspect files, monitor behavior, reverse engineer code, and analyze network traffic, each playing a unique role in overall process. Tools are usually grouped based on type of analysis. You'll often use them in combination. For example, start with PE Studio for static info, then move to Procmon for monitoring the behavior. PE Studio is perfect for initial triage. It's lightweight and shows red flags like suspicious imports or signs of packing. This helps decide if deeper analysis is worth it. Procmon gives you real-time view of what malware is doing on your system. It especially useful for finding persistence techniques, dropped files, or changes to your registry. If malware communicates with a remote server, Wireshark can expose that. Look for strange traffic, DNS tunneling, or post request with base64 encoded blobs. IDA is a powerful but a complex tool. You won't reverse engineer an entire binary immediately, but knowing how to identify key functions and strings will accelerate your understanding. Welcome. In this session, we'll explore two core methods to analyze malware: static and dynamic analysis. You'll understand what they are and how they are different and when to use each one. Static analysis means we look at file directly without opening or running it. We'll check things like file's format, function it calls, or any readable text inside. It's safe because we are not letting the malware execute. Dynamic analysis is when we actually run the malware in a virtual lab or a sandbox. This helps us see how it behaves, like what file it is creating, whether it contacts a server or how it is trying to hide, but it must be done carefully in an isolated setup to stay safe. Key difference is static analysis gives us a quick, safe look at what malware might do, but it can't show us how it behaves when it's actually running. Dynamic analysis does that, but it comes with more risk and setup. In static analysis, you might find a function named create process, which hints the malware will create a new process. But dynamic analysis might actually show what it is trying to run, like launching a hidden copy of itself. In this session, we'll learn what hybrid analysis is and how it gives us the best of both worlds, static and dynamic analysis. Hybrid analysis means using both static and dynamic methods at the same time. We check file structure and code, and also watch how it behaves when it runs. This gives us a complete and accurate results. Some malware tries to hide its behavior or use tricks to fool static and dynamic tools. But when we use both methods together, we can catch more clues and reduce false assumptions. It helps analysts to work faster and smarter. Get command line A is a Windows function that returns a full command line string that is used to start a current program. The A means it gives the string in NC format. Static analysis shows that the malware may use command line arguments. Dynamic analysis confirms that it uses those arguments to install another file, choosing a right method. In this session, we'll learn how to choose the best type of analysis depending on the situation. Should you go static, dynamic, or hybrid? These are three ways we analyze a malware. Static is quick and safe, dynamic shows real behavior, and hybrid gives a full picture. The right method depends on what you need to find. Static analysis is the best when you want to understand what file might do without actually running it. It's useful when working on your own PC or when you are short on time. Dynamic analysis is great when you need to see what malware does. It's especially helpful for spotting network activity or how it survives reboots, but it must be done safely, always in a virtual machine. If you are working in a professional setting or with an advanced malware, hybrid analysis is what you need because it will help you reduce blind spots. If you are a SOC analyst and get 100 alerts a day, static analysis will help filter fast. If you find a strange behavior on a system, dynamic analysis will help further in the investigation. But for the threat reports, go hybrid.